session, and I got an email from Heroku. He's like, "We're doing maintenance right now, and you're not gonna be able to use it."
Oh.
And but that it was like from 5 hours ago.
Okay, because I need to use it for demo.
Yeah.
Okay. All right, so we're gonna get started. Today we're gonna learn about networking, but specifically using pods. So in the previous few lectures, we learned about networking. First, we learned about it generally, about how servers and clients work, how to communicate back and forth. Then we kind of showed you a couple examples using URL sessions. Actually, I should put my mask on. I just realized. Yeah, and then we learned about URL sessions, and we kind of showed you how to do it, but we didn't really show you the details of how you actually send these requests. That was on purpose because we didn't want you to actually work with the low levels of sending it. Today we're going to show you actually how people do it nowadays using what we call pods, or we can think of them as basically external libraries. Right. So before we get started, we have some announcements. So P6 is going to be your last project. There actually is technically a P7 after that, but we made it optional, mainly due to the feedback. We're realizing that some of the projects are a lot harder than we intended, so we didn't really feel like we should give you more work to do. So P7 is optional. If you do it, you get extra credit. But P6, basically, the next project due after spring break is your last project to do. So if that's your last project, what's going to happen after spring break? So after we finish this lecture on networkings, everything else is kind of supplemental, right? But that doesn't mean you shouldn't come to lecture. The remainings of you. But basically, the point is that a lot of what you're learning would really set you apart during the hack challenge, right? So we talk about animations, we talk about integrating a lot of other cool pods, and being able to integrate them really makes your app really stand out. And so we think that it's really important for you guys to learn the stuff we have in supplemental lecture because we purposely chose to include them. Okay, cool. So yeah, I was actually gonna run them with my phone, but I couldn't get it to run, so I'm gonna have to postpone this to next lecture. But basically what we're gonna do at the beginning of next lecture, we're gonna sum up all the good submissions we had based on our grading, and we got some nice shout out. Okay, cool. So let's get started with the lecture today. First I'm gonna talk a little bit about what external libraries are. So if you've worked, if you've taken 1110, hopefully most of you have, you guys have worked with the Turtle library, right? So that is a form of an external library. Right? Basically, what it basically is that you're using code that other people wrote, and you're kind of just calling functions from it, right? And the good thing about using external libraries is that you can accomplish things kind of standing on the shoulders of giants, right? You can use functionality that other people have worked out the details for, and you can kind of just call it. And that allows us to save time, allows us to work a lot, hopefully bug-free because we're kind of using a ready-made implementation from a somewhat reputable source, and it allows us to achieve a lot greater things. So here are a couple examples. On the left, we have a hero animation. So if you've used Eatery, I don't think I can click on this one, but if you've used Eatery before and you click on the one of the eateries, it kind of expands and there's an animation that's achieves through hero animation. On Google Maps, you can kind of scroll around, right? You have this little circle with a triangle on it, kind of showing where you currently are. You can actually use this display in your own app just by importing Google Maps pods and just setting it up using what they already have, and they're just kind of giving that to you. And the final one is Vaulty, which I think is really cool. It allows you to do these really cool animations, and it's just a couple lines of code, and it looks really pretty. And I think this is made by Airbnb. Cool. So, what are the? Okay, it's a door. Fine. So, how do we use external libraries? In iOS programming, we use what we call Cocoapods. There's a lot of other ways of achieving it, but we're teaching you guys Cocoapods mainly because it's one of the most popular, most used pretty widely, and it has a lot of 45,000 possible libraries that you can use, and it's very simple to get started and working with. And so in today's demo, I will show you how to kind of install and set up a project using Cocoapods. And if you've worked with Python before, it's very similar when you do pip3 install. And if you've used Node.js before, it's very similar to npm or Yarn for that matter. Okay, so this is kind of how it works. I will actually show the demo right now. So, okay, actually, before we even start, so I think you guys should go to the, stop. Here we go. So if you go to the textbook, where is my textbook? Okay, so if you go through the textbook, go to week 6, and then go to the project, and then go to message board. So this is your P6, your project 6, and this is notorious, well, not notorious, but like has been through the past few offerings one of the harder projects. So this semester we decided to give you an early start, and the demo I'm giving you today in lecture is basically going to help you get started with the project. Basically how you set up the project, how you understand the project, and we're basically going to implement the first networking call together. So if your version of the textbook looks a little different, like this is a little annoying as well, but just make sure that you reload. So our textbook is built on Gitbook, and Gitbook does this thing called caching, where if you like have opened it before and then I make a change, but you don't see the change immediately, you have to reload it before they actually can kind of pull the most up-to-date version. So if you reload it, hopefully you should see these 3 things. Over here is the Postman JSON, we'll get to that later. Over here is the starter file, and then over here is kind of more detail of how to set up Cocoapods. You can read this in your own time, but I'll kind of also be showing you basically what this article is going through. So what I want you to download first is this starter code. We're going to be using that in today's demo, and that's actually also what you submit for the project. And if you open it, I'm just going to drag this to my desktop. And I already have a starter. Okay, let me just delete this starter then. Close. Close some stuff. Okay, so has everybody downloaded it? Cool. So when I open this folder, you notice how there's only 2 files in here, right? And throughout all the past few projects, this is normal. This is how it's usually set up. But when you want to include like pods into your project, you will have a lot more files. And the most important file here is called a pod file, right? And the pod file looks something like this, right? And what this basically is a list of pods or external dependencies that your project will use, right? It's kind of like a list of libraries that you will use in your project. And well, how do I get this pod file? First thing you want to do is open up terminal. Okay, I'll close it and open it again. So open up terminal. So all Macs have a built-in terminal. If you type in terminal to Spotlight, you would get something like this. And my terminal might look a little different from yours because I have some custom stuff looking in there, but it should function exactly the same. So a very quick crash course on what the terminal is. It's basically a way for you to interact with your computer and run a lot of functions just by typing in lines of code. And one very important idea is what we call directories. You can think of directories as just folders. So right now I want to work with my projects here. So I basically need to tell the terminal to kind of come to this project directory or this folder over here and then start working here, right? So right now it starts off like home, right? And you kind of like guide it to your project folder. How do I do that? I need to change its directory. And that's done through CD. So there's one way of going to this directory is you press tab, and it'll give you a list of possible places you can go. Let's say I want to, right now I put it on my desktop, so I'm just going to go to my desktop, press tab, it auto completes, press tab again. It tells me what there is. I called it P6 starter, press tab again. Oh, sorry, P6 starter, press tab again, and it completes it, right? And I press enter. Now it says desktop P6 starter. And if I want to double check, I can press ls, which tells me what's in my directory. And it says networking, networking.xcode proj. So this is exactly what I have here, right? And another faster way, say you have a lot of folders, right? What you can do is you type cd, and you just drag and drop your folder in, right? This basically fills in the path, where you press enter and it goes straight there. Exact same thing. Okay. Oh, and I sorry, I just typed clear to like remove the stuff, so it doesn't like clog the terminal. Okay, so has everybody changed their directory to P6 starter? Cool. So after we have this, now we want to kind of get our pod file. The way we do this is really simple. We just type in pod init. And what this does, it initializes this directory, right? And it basically tells my project, this project is now not just a normal project. This project will now use pods, external pods, right? and it starts by basically creating this pod file. And so as I said just now, this pod file is like a list of libraries that you will use. And the way you kind of set up this pod file is, there are multiple ways, but the most simple way is just clicking on it, double click, and you just open it. And when you open it, you can start adding new pods. Yes, you have a question? Oh, yes. So some people, I forgot this, my bad. So some people don't have pods installed yet, and before you do that, you need to install it with this command.
And that, I think, will take quite a while.
Mm-hmm.
Some people have it natively installed.
Yeah.
Oh. I don't know if they do.
Yeah. So sudo gem install Cocoapods. Are you guys still installing it? I guess no one's going to help you with that. Oh, so yours works. Okay, cool. Okay. So you're going to do that. I'll do that. Cool. Does it work for you? Okay, cool. Do you know how to turn off your Bluetooth off? All right, I'm just gonna keep going, because we do have some stuff to cover today. But basically, after you install Cocoapods, you should be able to use like pod commands. You do like pod init, pod install, and stuff like that. So let's just backtrack, right? So what did I do just now? I'm just gonna delete this pod file. Basically, I call pod init. It initializes the directory, kind of saying this project now is going to use Cocoapods, and it creates a pod file for me. The pod file we talked about just now is like a list of libraries that you're going to use. So the way you kind of specify, I want to use a specific library, is you open the pod file, and then you just you like directly type in which pod you want to use. So you say pod, and I want this, in this lecture, I'm going to show you how to use Alamo Fire. So Alamo Fire. You save it, and you close it, and that's it. You've basically specified that you want to use Alamo Fire. And after you've like kind of added all the pods that you want to use, you do pod install, right? So now you're saying, I've like decided what pods I want to use. Now can you download all the pods for me? You do pod install, and this is going to run for probably a couple seconds. But basically what it does, it goes through your pod file, right? And it installs all the dependencies that you've listed. Now, after you've done this, you notice that there's a bunch more files, right? We have the pod file that we just touched, right? The Xcode proj, which has been there before, and the networking, this is kind of like where all source code is, right? The pods here, this is basically a folder where all like the pods that you specify are going to get downloaded. This you don't really have to touch. Podfile.lock is kind of a way for like this version management to basically make sure that you don't have like older versions or like corrupted versions of your pod installed. That you don't really have to care about. What you really do need to care about though is this XC workspace. So previously we've all been opening the network Xcode proj, which is this blue file. But after you've installed pods, you want to open this white file, XC workspace. And the reason why is because now you have pods, and if you want to like make sure that when you run your project, you also consider and use the pods, you need to open the entire workspace and not just the source code. So if you open the workspace, you notice how the pods are also listed down here, along with like the code and like the functions that we're going to work with. Okay, so that's the demo for installing Cocoapods. There's a little bit of hitches, but hopefully you guys managed to get it installed. So now the structure of this rest of this lecture is I'm going to kind of explain how you do networking with like a little small example on the screen, and then I'll kind of just open up the project and we're going to work together and implement the first route. Okay. Cool. So that's the pod file. We just did the demo. Now let's talk a bit about how we do HTTP requests in our iOS apps. So in the previous lecture, we showed you how to do it with URL sessions, right? But Alamo Fire actually makes it a lot easier, right? Alamo Fire is actually based or built upon URL sessions. And if you really wanted to use URL sessions, you still can through Alamo Fire, but it really removes of all like the ugly detail that URL sessions would have had. So if we want to be able to use Alamo Fire and its powerful kind of networking abilities, we need to understand like how closures work. And I'm just going to give you a quick review of how closures work. So a closure is kind of like an anonymous function, if you've heard that before, but it's basically a small, like a self-contained block of code that just runs by itself, and it can be passed around kind of as a variable as well. So here's an example, right? Say I have this odd filter closure, right, that takes in an integer and returns a Boolean. And what it does, we can kind of see, right, based on the, you can't see my cursor, but if you see this num over here, right, it says num in, and then it says return num, that's the modulo sign, hopefully you've seen that before. Modulo 2 does not equal to 0. What that basically means is that if the number is odd, return true. If that number is even, return false, right? Since it's integer, sorry, takes in an integer, returns a Boolean. And we can pass in this closure as a parameter to the filter function, right? And what it basically does is it calls our closure, right, on every one of the numbers, and odd numbers would then be set to 1, 3, and 5, right? This is an example of a closure. But probably an example that hits more to home is an example like this, right, where if you've implemented P4 before, this will look very familiar, right? You have, say, items you want to display. That's one variable, right? That's like the thing you probably link up the table views data source to. And you have this all items array, right? Which is like the entirety of all the things you can display. And there are multiple ways of implementing this, but a rather clean way of implementing this would be using the filter function, right? So you filter over all the possible items you have. You run your closure on it. It basically checks whether or not this item is like contained in the active filters, or whether or not you want to like display the item right now. And then whatever the result of running this filter function, right, is assigned to display items, and you use that to kind of hook up with the table views data source. Okay, that's another example. So closures and networkings is really important because often when you have networking calls, it can take time. So let's consider an example of, say, a app that has a profile picture, right? When you open a new person's profile, it kind of makes a call to like some backend, right, or some server, and it requests for the photo. But what if this photo is very high definition, right? This photo can take a long time to, so the response to the server takes a lot of time, right? Because it has to take time to kind of dig up the photo, has to kind of like bring it down to like bytes and then send it to you, and that like process of sending it back and forth can also take time, right? And if your app just stands there and waits for the photo to come back, it just lags, right? Like the app waiting is equivalent of the app freezing, because when it's waiting, the app can't do anything else. So the way we kind of work around that is we have a closure which kind of functions as a callback. Hopefully that sounds somewhat familiar, but the idea is basically, along with the request, we also send a little chunk of code. And this chunk of code, basically what we're just saying is, after you've given me like a response, right? So I send you the request, and I just forget about it, right? But when the response comes back, I want you to call my chunk of code onto it, right? That's the purpose of the closure here. And you'll see in the couple of demos later on that this closure is used extensively. It's used a lot. So, okay, now this is kind of going into the demo now. So we have, before I even show you this, I can show you the assignment this week. So this week's assignment is basically, I got rid of the thing. But this week's assignment is basically building on your P5 last week, right? In P5, you built out the kind of structure of a messaging or a posting type of app, where people are able to add new posts, they're able to delete posts, they're able to refresh posts, they're able to update posts and stuff like that. And this week, we're going to implement the networking for that. So one of the first network requests you need to implement is this get all posts type of request. And okay, so we can get into the Postman now. So the endpoints for all the requests are all listed here in this GitHub, and this is linked on the course textbook. So you can just like, from this point onwards, right? These are all requests now. So this is a get request to the the host endpoint. This is the get request to the hello endpoint. This is the get request to the post all endpoint. But if it's your first time reading this, this may be a little bit difficult to understand. So I've made a Postman collection, which is very helpful for kind of like debugging the endpoint. And so, how do I import this, right? So first, what you can do is if you download this JSON, or if you click on it, it will open to you a new page. And if you open Postman, okay, so I already have it here, but I'm just going to delete it. Lecture 11 demo. So you don't have to create a new team because you wouldn't have anything in your workspace, but I have a bunch of other stuff, so I'm just going to create a new one. But what you want to do is, after you open Postman, you'll see this kind of bar on the left-hand side, and there's the import button. If you click import and you click raw text, you can copy and paste this JSON, right? And I got this JSON just by clicking on this. Copy and paste this JSON into here, into a continue. And it says project 6, message board, Postman collection v2.1. That's perfect. Import it. Takes probably a couple seconds. And then now when you open it, all your endpoints are all here, right? So if you click, I'm just going to open all of these. We have the retrieve all post endpoint. We have the retrieve post by ID endpoint. We have the create post endpoint, update, and we have the delete post endpoint. And if you want to kind of see what an example of a response and an example of a request body looks like, if you click right underneath, it says EG, right? As an example. Go to this. So this example is like, you can't edit this, right? But you can just see how a sample request and a sample response looks like. So over here, in this demo, I'm going to show you how to implement the get all request. So let's, so we can see the structure of the request, right? So it starts off with HTTPS iOS course messageboard.heroku.app.com, right? That's like the domain we talked about before. And then after that, we append /posts and /all. So that's like the get all posts type of endpoint. And this is a get request, right? Remember get requests? In the get request, we have parameters. And over here, we don't actually use any of the parameters, right? This is a very simple get request with no extra parameters. And so with the get request, we kind of retrieve information, right? So we retrieve basically all the posts we have. And so the posts are given back to us in the form of an array with a bunch of posts. So this is like the structure, right? Now let's get into how we actually use this structure in the actual project. So what I showed you just now is basically the screenshot, right? The screenshot is the post, right? Like up top, you can see like the domain, and on down here, you can see the actual response, right? So now I kind of just put this on you, right? But this is the equivalent of this in the previous slide. And I'm going to break this down line by line, so hopefully it becomes less daunting, okay? So the first thing we have up top, this is the endpoint, right? This is, you know, like before, I think on Monday last week, we did a demo of kind of using Postman to kind of like fish out the password of something, right? We're sending requests, and there's one thing at the beginning that never changes. That's the host, right? Or like where the entire thing is hosted. And the way you kind of access the different endpoints is you kind of add like /this/that at the end of the host. So, you know, instead of just copying and pasting the entire link multiple times, you can just define a variable called host, and you kind of use string interpolation. If you see on line 3, right, /let endpoint. Down here, you can see that I basically use string interpolation so that I can add the /post and /all at the end without having to copy the string multiple times. And we're doing networking, right? So we want to send our request to this endpoint. And so this is what this like kind of structure looks like, right? So AF stands for Alamofier, right? Alamofier is going to send a request. Where is it going to send its request? It's going to send it to this endpoint. That's the first parameter you passed in. And then what request is it sending, right? So the request that it sends is a get request, right? This is the example I'm showing you just now. And you specify it by basically passing into the method, into the method like parameter of the alamofier.request part. You specify, right, which one it is. You just do a period and you put get, right? If you're sending a post request, then you would do dot post. If you're doing a delete request, you do dot delete, okay? And this kind of corresponds to like this get on the Postman, right? Like on the Postman, remember there's like this drop down that you select. This is the exact same thing, right? Over here, instead of putting it as a drop down, you're kind of specifying what your request method is in the parameter of this request function. Okay. Now, what's this validate, right? Remember when we talked about response codes? When you set a request, the server will tell you what's going on with your request. Say, for example, you're trying to log in. You send a username, you send a password, and you know, what if your username and password are wrong, right? So the server will kind of respond with a response code telling you kind of how it's going, right? If it's like 200 something, then it's success. If it's 400 or 500 something, then there's some type of error, right? So this validate function is built into Alamofier, and it basically does all the checking for you, right? It basically returns some result, and that result is an enum, which we'll see down here later, but basically it splits into either success or failure, okay? So if it's 200 to 229, 299, sorry, it's okay, and otherwise, if it's not within the 200 range, then it's a failure. So after it validates that, now you kind of want to parse this response, right? Noah kind of went through this in terms of like codables in the last 2 lectures. But basically, you take this response data, right? So you do dot response data. You're kind of saying, okay, after you validated it, now I want to open. I want to basically, I want to like process this response data. And how do we process it? This is where we use our callback, right? So notice how we have this bracket notation over here. Our closure basically kind of processes whatever is in the response data. And so remember when I talked about the validation just now, how it breaks it up into a success and a failure case? This is where it's kind of checking it, right? You basically put the response's result into a switch, and you see if it's either success or if it's failure. So let's first talk about the success case, right? So imagine just now, not imagine just now, but like kind of recall from just now. I showed you the example of a response, right? So what did it respond with? It responded with kind of an array of JSON, right? And each one of these kind of JSON objects contained a representation of a post, right? And as you already have implemented in P5, like the codable or like the struct of a post, right? It has like the ID, it has a timestamp, it has a poster, it has a title, and it has one thing else I forgot, but it has 5 things, right? So this is the part where you're kind of decoding it, right? Because after the server responds to you, it just sends you a string of text or a string of bytes, and you kind of need to tell it, right? This is actually a JSON, and I need to take apart like the pieces of data that I want to. And the way we do that is we basically first define a variable called JSON decoder, and you can actually also do this in line. Like you don't have to define the variable and just put it in here. But sometimes you also want to specify, like for example, if you want to turn like the casing of the keys from snake case to camel case, then you can just do it in here, right? You just chain it, and then you just use JSON decoder once. And this will kind of be more relevant when you do the hack challenge, where the backend is kind of using one set of, because they're using Python, so then they're using snake case, or we're using Swift, therefore we're using camel case. So there's a little bit of a difference there. But for now, just kind of defining up top and putting it here, right, is basically the same thing, okay? So this JSON decoder is in charge of turning whatever response is, that's like a string of mumbo jumbo, and it turns into this, right? Beautiful JSON that we can work with. And this is what I'm going to show you later in lecture, but later in demo. But a lot of the times you can kind of like work around like this decoding process by basically making your post struct conform to codable, and then you just decode it just by passing in like the data directly. And basically how it works, right? It just matches the fields you define here to the fields that they have in the struct. In the response JSON, right? If the type and the name matches up, then it's fine. You're great. And then you can just work with the data. If it doesn't, then it will throw an error. So actually, I'll go back here. So the error is kind of handled here, right? You're using an iflet, and you're trying to decode it, right? So this is the stage where, so this is the stage. This I'm pointing at like the bracket post.self, that part, right? That part is where 99% of the networking errors kind of come from. If you fail to decode it using the right type, then it will fail, right? So you're kind of trying to decode it. And if it fails, it'll go to this else case, and it will print fail to decode, get all posts, okay? So this kind of leads to my next point. This is really important, right? You basically want to match whatever type here, right, in the decode part to whatever the response is from the networking call, right? So over here, this is given to us as an array of posts, right? Like I think it's cut off a little bit, but there's like an array here, right? So it's given to us as an array of posts. So when we decode it, we also need to decode it as an array of posts, right? Hence we have an array over there. And then over at the end, like from data, you just pass in whatever the kind of server responded you with. So that's the success case, right? After you kind of decoded the user response, then you can just work with that, right? And that's kind of, we just tuck it to the completion, and I'm going to talk about that later. But the completion basically is like, okay, my networking request like worked, right? What do I want to do with my data now? And then like the completion is kind of like the blanket term of what do I do with my data, right? You just call the function, because like you define that function, right? And you pass the data in. And that is like the end of your networking request. But that's assuming that you succeed, right? If you fail, then you kind of want to know why you failed. So there's probably more sophisticated things you can do. You can like print out not only the error, but you can also print out the error code. You can also print out how long it took for the error to happen. Maybe those can all like tell you what kind of caused the error. But if it's just like a simple assignment, printing out the localized description is more than enough, because the localized description is basically like a string of English describing kind of what the error is, right? Okay, cool. So that's kind of breaking down how the Alamo file request works. Now let's get into the demo of actually sending it. So if you've downloaded the project, I'm just going to run it right now, and let's see what it looks like right now. So we've had some issues where students weren't able to fully complete P5, and if you can't complete P5, you're going to be in a little bit of a trouble for P6. So what we decided to do is, whether or not if you want to, you can choose to work on our template for P5, which is basically like, sorry, a template for P6, which is basically the solution to P5. And you can kind of just use this to send your, to create your network code. If you want to use your own P5, all you really have to do is copy over this network manager, right? And just implement your like network calls in here. And then you would link it up to however your view controller or however your table view cells are set up. Okay? Cool. So let's get started with implementing this. I'm just going to move my face and put this on the side.
You said that you gave out a template for
P6? Okay. So we're going to implement this one first. So we can forget about all this down here. We're just going to implement get all posts first. So get all posts basically is exactly the same as what I showed you here, but I'm just going to walk you through how I do it, right? So when I'm sending this request, right, first thing I actually need to do, I forgot to do it, is I need to import a LAMO file, right? Because that's basically the basis for what we're doing in terms of sending the requests. So remember, we don't access it using a LAMO file. We access it using AF. If you like search online, you might see some that still use LAMO file.request and stuff like that. That's the old syntax. We're going to show you like the newest syntax. So it's best if you kind of follow along with what we show here. And if you do request, you can see that there's like a bunch, right? There's quite a lot. I'm just going to pick the one with most stuff, and I'll explain to you what each of these are, right? Convertible, this part is just the endpoint, right? So actually, before we even said that, let's just define the endpoint. So the endpoint is, I can just take it out from Postman, right? I see that the endpoint is this, right? But notice how I already defined this host here. So what's the difference between the host and the endpoint? It's just this bit at the end, right? It's like the /post/all. So what I can do is string interpolation. So I pass in the host, or like whatever the string the host is, and then I do /post/all. And that's the endpoint for my get all posts get request. So I pass that in here, and that's the first parameter. The second parameter, right, method. This should seem a bit familiar now. This is basically what type of HTTP method I want to do. This is a get. The parameters over here, you don't actually have to use for now because this get request does not have a body, right? And this is a little bit confusing, but this parameters here is actually what the body of your request is. So let's consider an example, say later on when you keep working on P6. The create post has like a body, right? You want to send it to this endpoint, but you also want to send some JSON over, right? So how do I define this? This is where you would kind of like create like say params that conforms to a string. I'll explain what this is in a bit. And this is equal, this is equal to key value. And then you pass in params here, right? And so say, for example, the body of your get or post request is kind of a JSON that contains one key that has the key value of just the string value, right? That's how you would send it. This is basically the body. The naming is a little bit confusing, but just make sure that there are two things you want to be very careful of. First of all, you must make sure that it is of type string, right? This is kind of like saying it's a dictionary of type string that maps to string, because that's what a JSON is. And the second thing you want to be very careful of is when you're actually sending a body, you must specify the encoding of it, right? So there's a very common bug where basically if you don't specify the encoding, it treats the body as just stuff it shoves in the URL, right? And that is a little different from what Postman does, where basically in Postman it puts whatever the body of this post request, it sends it as part of like the parcel, right? So like if we go back to the analogy I used last week on Monday, if you shove something into the URL, that's kind of like writing on the surface of the letter. And if you send it as the body of the request, that's like putting it inside the letter, right? So make sure that you kind of specify the encoding here. And the way we want to, the one we want to have here, right, if it's actually a part of the body, is JSON encoder, JSON parameter encoder, right? That's basically saying the parameter, or like the body here, I want to basically say it is a JSON. I'm not sending raw string in the URL, I'm sending a JSON. And just do .default. There's other ones, but default works fine. Okay? Cool. But, as we said just now, right, we're working on a GET request with no body, so we don't actually need this. I'm just going to delete this. But this is very helpful when you're working on the other requests down there. Okay, so let me get rid of this and get rid of this. And so the rest of the stuff here, the header, the interceptor, and the request modifier, these are what we call middleware. We don't have to worry about these at all for now. In fact, you won't have to worry about them probably for a while. So we can just get rid of this. So this is actually your request, right? Looks pretty clean, a lot cleaner than what you could have done through the URL sessions. But you don't just want to send a request, right? You also kind of want to process. The response and kind of do something with the request, right? So that's where the kind of validation part comes in, right? We showed just now. We make sure that the request works, right? Because if it doesn't work, then who cares what you send, right? You're probably not sending me anything meaningful. And now we kind of work with what the response is. So actually, I think I did that a little bit fast. Let me do it one more time. So if I do .response data, right, and I press enter, notice how the terminal is kind of still highlighted. Xcode is still highlighted on AF response data arrow void, right? It's kind of highlighting this completion here. And if I want Xcode to kind of help me out and write the syntax for the completion, I press enter one more time, and it kind of gives me the structure of it, right? So what this is saying is response data is going to take in some response. So I'm just going to call it response. And it's going to do something to the response, right? So over here, I would process the response. Okay, so how do I process the response? That's dependent on whether or not the response worked or not. So I create a switch case here, right? So I create a switch for the response's result, right? And if you look at the description of it, it says, right, it tells me whether or not it succeeds or not, basically the response as the result of the response serialization. And with switch statements, right, you basically write a case. You say if it succeeds. And if it succeeds, we get some data, right? Because it succeeded, then the request kind of responds and gives you some information that you want to work with. So I'm just going to call this data, right? And for now, I'm just going to print it out, right? I'm going to implement this later, but for now, let's just print it out, okay? What's the other case? The other case is if we fail, right? So if we have a failure, then this is going to contain an error, right? So I'm just going to call this let error. And here we also just want to print it out. But remember, right, if we just print out the error, we get this big blob all over the terminal. We want to actually understand what the error is. And in Swift, we have this thing called a localized description, which is basically a string of English that describes what the error is. We can print that instead. So the failure case is actually done. Now we're just implementing the success case. Okay, cool. So for the success case, right, after we get the data from the response, we want to turn it into JSON, right? You kind of parse it into JSON, and just now I showed you we need a JSON decoder, right? So that JSON decoder is equal to JSON decoder, and over here you can talk about the casing and whatever, but we're gonna forget about that for now because we set up both the front and back end, so we know what the conventions are. But later on, when you work on the hack challenge, you may need to add a couple more specifications here for the decoder, okay? So after we have this decoder, now we want to use it. So we do an iflet here. User response is equal to try of JSON decoder dot decode. And if this works, then we can work print user response. Else print failed to decode get all posts. Okay, so what did I do just now, right? Just now what I did is I basically created two possible cases of when I try to decode the JSON, right? Either it worked, right? So I specified a correct kind of structure of decoding, which I haven't typed yet, but it's going to be right here, right? So how to decode, basically, is I write it here. And I pass in what I need to decode as the data, right? And this we can just say data because we already, oh yeah, this is data. It's because we defined that there, right? So it works. Either if it works, then we can work, we just printed out what the data is and we work with it there. If it doesn't work, then we kind of tell the user, right? We failed, So we print failed to decode get all posts. And remember how I said this is like very, very important? Oh, I added a space. Oops, it's not supposed to be there. And remember how I said this is really, really important, right? So how do I decide what the structure of what I want to decode is, right? Two ways. You either look at the documentation your backend member gave you, or you use Postman, right? Because you can try sending a request, assuming that you know how the body looks like, right? You send it, and it gives you a list, or like it gives you basically a response. Oh, there's a lot of posts. But it gives you the response, right? And if you notice the structure of this, right? It's an array, and in the array, it has multiple of these kind of JSONs. And if you look closely, you notice that these JSONs are basically the structure, like they all have the same structure, and they basically represent a post. So what we want to do here is we want to decode an array of posts, right? So we do array posts, and then .self basically is like there's an extra tidbit that you have to add. Basically, you add it every time, but you can just think of it as like you define the structure of it, and you do .self to basically get the actual type. So this actually won't work just yet. And the reason why is because I talked about this idea of kind of decoding this JSON into some post, but I actually haven't implemented that yet. So let's implement that right now. So if you go over to posts, right now it looks just like some class, right? And this is just like, this is a template, this is like a placeholder, but we don't actually want any of this, right? We want it, actually let's keep it here for now, but we want it to conform to codable, right? And the reason why is because when it conforms to codable, it allows us to basically turn it from some string into JSON directly, basically the way it works, as Noah has basically has already talked about in his lecture, but it matches the parameters in the top one by one, right? And if it matches, then it's great, and then it returns you the JSON. If it doesn't matches, then it errors. And the error case is handled here, right? It says fail to decode get all posts. So let's kind of create this. Let's create this decodable right now. So I want to create a struct for post, and because I already defined it up here, I'm just going to comment this out. But we'll create a struct for the post, and we want it to conform to decodable. So what do I pass in here? We basically match one line, like one by one, of what the key and values are, what the keys are in the JSON. So there's one small quirk about JSONs, and it's like the ordering is not enforced. So there's one, it's possible that it's like body, timestamp, poster, ID, and title, but the next time you send a request, it could be like a title, poster, ID, timestamp, body. Like the order is not enforced. So the order doesn't really matter here. If you really want it to be strict, you can like alphabetize it, like have it in like alphabetical order. But for all that matters, it doesn't really matter here. So I'm just going to use this and define it here. And so now basically we have our post codable. And if I build it, it'll work, right? Because now it understands what post is, because I defined its codable, right? I told it how to decode some string into a JSON, and then the types are matched up. So this get all posts request is complete. Now let's see how we actually use it. So in the boilerplate of this code, of this project, we kind of have a bunch of UI elements set up for you. So I'll go over it very quickly, but hopefully most of this should seem very familiar because we've kind of already been working with a lot of these anchors and constraints before. But we basically have one big table view, which is this thing down here, and it has like rows, right? So it's like each row is represented by a table view cell, right? And two things to notice: we have a filter button, right? So if we click on the filter button, we can filter by the ID of the post, which just gets one specific post, or we can filter by like a poster, which gets basically all the posts from one poster. We can also add a new post, right? We click add new post. We have title, Justin's my name, and oh, sorry, no, that's the wrong one. This is body of my post, and this is Justin, which is the name of the poster, and we click create. None of this works right now because we haven't implemented any of this. But what I'm going to show you today is how to implement the refresh part, right? If I refresh it, I basically want to get all posts and display all the posts, right? That's a simple functionality we want to do right now. So where do I do that? I've kind of added to-dos everywhere for you guys. So if you just command F for to-do, you can see where you want to be implementing it. right? But if we think about like where the refresh functionality should happen, right? That should happen wherever we call refresh. So let's look for the refresh function. And we see we have a function called refresh data. And we kind of describe what to do here, right? So we want to basically retrieve all the data with the get all requests, which basically is what we implemented over here, right? We want to retrieve all the data using this get all post, sorry, not request, get all post function. And based on what we retrieve, we want to kind of like add it to the array and display that, okay? So, oh, I lost my refresh function. Where'd it go? It's here, okay. So let's implement this right now. So you see this thing dispatch queue.main.async after. I'm just putting this here as a placeholder, right? Because right now when I refresh, I want it to like kind of look like it's refreshing for a couple seconds and then be like, wow, I've refreshed, but it actually have refreshed, right? So when we actually have finished implementing this, like this function here, I can just delete this, right? Because this is just simulating a delay. But when we actually do a network request, right, as we talked about before, the actual request does take time. So this is perfect, right? So all these functions here are what we call static functions, right? In the sense that I don't have to create an instance of Network Manager. I can just use the functions directly. And that's exactly what we want because we basically put all our networking requests in the folder just to clean it up, right? We could definitely have put it just all over view controller, but it looks a lot, like it looks very messy. So in terms of cleanliness, we basically put them all in the Network Manager and we add them as a static function. And we access them basically by doing Network Manager, and then we get the relevant function, right? So all these functions, like the stubs are all there, but the only one we implemented was get all posts. Okay? So Network Manager.getAllPosts, that we've already implemented. That basically gets all the posts that we have in our server. And now we do the most important part, but how do we process the response? And notice again, right? Xcode is highlighting over the closure. If I press enter one more time, it kind of fills in the syntax for me. And this time, notice how it's highlighting over the array part, right? So this is telling me that this closure takes in an array of posts. So I'm just going to call this posts, right? And it does something to it. So I know that the closure is only run when my network call succeeds. So what do I do to all the posts that the network call sends back to me, right? I want to add them to basically add them to the posts that I'm displaying, right? So the way this project is set up, and you can like in your own time, you can kind of look through and understand all the variables, but the two most important ones here is post data and shown post data, right? This looks a very similar idea of like, you know, one array storing all the data, one array kind of showing the filtered version. So if I'm getting all the posts, I basically want to add them to all my post data. So self.post data is equal to posts, right? So now, after I did this, post data contains all the updated posts. Then I also want to make sure that what I'm showing is up to date, right? So I make sure that the shown post data is equal to self.post data, right? And this is, like, it looks a little bit redundant because, like, post data is storing the exact same information as shown post data. But later on when we implement filtering, right, like, even though you're filtering by, like, some, like, filter, you only show some certain amount of data, you don't want to delete all the other data you have stored, right? So that's the purpose of separating it into two variables. So now I've updated both my data variables, right? Remember, the most important part, we also need to run a refresh, right? Because now the data has changed, but we have to make sure that, you know, we're displaying the up-to-date data. So the way we do that, we get the table view. I think it's called post table view. Yeah. Dot refresh. Sorry, reload data. And that basically kind of like reloads what we're seeing, and it uses basically what is in its data source, which we kind of define as the shown post data. And finally, since we're kind of doing this refreshing action, right, we want to basically tell it to stop refreshing. And that's basically all you have to do to implement this. So if I delete this, remember this was just a placeholder, right? I can delete it now. If I delete this and I run my project one more time, now the refresh should work, right? So right now I have all this here, but if I refresh it, give it a bit of time. And so when you're working with a project, this might happen, right? Where it takes a little bit like long, it takes like a little while to actually respond. And that's normal because we're kind of hosting our backend on Heroku, which basically is if you don't kind of send requests to it for a little while, it kind of falls asleep. And then it just, the next time you send a request, it takes some time to start back up again. So just to make sure that it's working, I'm going to open up Postman and send some stuff to it. Looks like it's working. So I'm going to run my project one more time. And then let's try to reload. Okay, something is wrong. We realized that we kind of forgot to handle the request, right? So just now the reason why nothing was ever working, nothing was ever being displayed, is because we used the completion on what is being responded, but the completion is not actually being called here, right? So we need to make sure that in our network request, we actually use the completion, okay? So the completion is passed in as a parameter, right? So in previous assignments, we kind of had you define the completion here by yourselves, but this caused a lot of issues, so I've just, this run, we're just giving it to you. But basically, what's going on here is that you take in a list of posts, and you do something to it. That's all this is really saying, right? And the escaping parameter is basically, in like layman terms, I wait until the requests finish, then I call the completion, right? Normal completions, they run instantly. So after you call the request, it just calls the completion. But if you want to wait till the request is done, you have to add this escaping decorator. That's all it really is. So now I need to use the completion, and it's actually just a one-line fix. I call the completion on my user response, and that's it. I make sure that I actually use the completion that's passed in. And if I saw this yellow triangle just now, I wouldn't have made that mistake, but I did it. So now if we run it and we reload it, we see that these are actually all new messages, right? It says, Mr. Sir, can I get an extension? That wasn't there before. And these are all like the new, posts. Okay. So actually, now that since we're all here, I can show you what the completed version looks like. So this is the completed version, right? So if I reload, I'll get a bunch of posts, right? And if say I want to add a new post, right? I can be like, I love breakpoints, and then Noah. Oh no, sorry. This is the body. Breakpoints are great, and then name is Noah. We click create. We'll create a new post down here. You see, and you can also filter it, right? So say I want to filter it based on the ID of the post. I can just basically get the ID of the post, and then pass in the ID of the post here. Click filter, and it'll get the specific post. And if you choose to implement the extra credit, you can also filter by, say, the poster, right? If I spelled it correctly. And if you click filter, it will filter by like whoever posted it, right? It'll give you all the things here. And if you want to refresh it, it also works. And there's also, you can also delete it, right? So to delete it, you click on the post, right? And you put in the poster. So over here, you see in bold, the poster is Noah. If I click delete, then it gets deleted, okay? All right. That's all there really is for this lecture. So hopefully that helped you kind of get started with P6. P6 has notoriously been pretty hard, so hopefully like this kind of helps. And if you have any questions, feel free to reach out. This is actually due after spring break, but if you have any questions, you can always come to us before spring break during office hours. Okay?
I just want to say one thing. So can I point out?
Yeah.
So this code is slightly different from what I showed, mostly because of this if-let here. So this is somewhere that you might get errors. It's something that's caused a lot of problems in the past. And if you want to debug this, I very much suggest putting this into a do catch block instead and printing the error, because it'll be more descriptive than what's happening right now. There's also a very cryptic error if that happens, and there's something about like converting floats to integers. Something that you should try is just setting the decoder's date format to be, to be ISO, this really random thing. And then lastly, everyone's using the same database. So please keep it like appropriate. Thank you. That was kind of annoying to deal with last semester. Yeah.
Yeah, that's all. All right, let me end the recording.